Hi guys, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In this specific discussion, we're going to look at one of the applications of the concept of entropy. And as we said, of course, as we discussed various concepts and topics, we are going to find major areas of application, especially in our day-to-day life. Now, in this particular case, we're going to consider the efficiency of a reversible cycle. And this, of course, is going to be one of the aspects of entropy that we had mentioned. So I've said that we can be able to describe the change in entropy as a Q reversible all over T. And of course, we're going to see that considering a cycle, a concept of a cycle, a reversible cycle, then therefore we're going to get an idea that we can be able to describe the concept of efficiency from this specific relationship. Now, the concept of entropy, therefore, is going to be employed in coming up with various expressions describing this aspect of efficiency. And of course, in this case, we're going to consider the efficiency of an engine that is going to be, or that is going to be involved in conversion of heat into work. And of course, it is going to find a relevant application, especially in our similar cycles which are employed in our various aspects of our day-to-day life. So in this case, this specific engine that we're going to consider is going to function in cycles. And this concept of cycles that I'm talking about, of course, are going to consist of successions which are going to result in a system returning to its original state. Now, in this case, then, therefore, we're going to consider the properties of a system and mention the concept of temperature and pressure, and perhaps we're going to also see the aspect of heat, which we had mentioned being represented in form of a Q. So these are some of the variables that we're going to consider whenever we're going to look at this specific aspect of the aspect of efficiency of a reversible cycle in this order. So therefore, we're going to look at this specific process in terms of energy, and for a particular system like this, the internal energy change, we're going to see that the overall internal energy change is going to be given as 0. Therefore, for us to find the efficiency or the aspect of work from this specific, of course, process, we're going to consider the net heat that is absorbed into the, of course, system. And of course, the maximum work can be described from the process when this process is carried in a reversible manner. Thus, the efficiency of this specific work is going to be obtained from this specific aspect of a reversible cycle. Therefore, in my discussion, I'm going to employ the concept of a specific cycle that I'm going to refer to as a Carnot cycle, and that is going to be done in a different video from this, which is going to give us an overall overview of the specific variations of these particular properties that I've mentioned of the system that are going to be going in cycles and assuming the original shape, so that original state. So that is going to be in form of the concept of considering the aspect of entropy and temperature, whereby we're going to consider entropy and temperature using different states, of course, which are going to be describing the aspect of the Carnot cycle that I've mentioned. So basically, this was an introductory video of trying to give the essence of efficiency over these specific cycles, so that in case we come across this one in a figurative way, then we can be able to have a concept of what basically that one means. So therefore, as I've said in summary form, this concept of entropy is going to be very relevant in trying to find an expression for describing the maximum efficiency of engines. And these engines are going to be employed in converting heat into work, energy, and in form of a work, of course, as I've mentioned. Now, from the first law of thermodynamics, we said that we can give a relationship between this specific aspect of our work, especially in expansion and compression, using that particular representation. Therefore, we said that this can be given in terms of a work of expansion given as, of course, W. Therefore, the relationship between heat involved in this particular engine and conversion of heat to work is relevant for us, and finds we find it as one of the ways of application of this aspect of heat and entropy. So therefore, catch us in our next videos. We're going to look at a reversible process that is going to result in, of course, work and, of course, the description of this maximum efficiency of converting this heat into work from this reversible process. So that is it for now, guys. Catch our next video, and of course check our links of various videos for description boxes that we're going to put some links, and of course engage us in the comment section. And also I'd like to encourage our members to subscribe so that we form a large community of members who are getting updates on similar topics under discussion. So that is it for now, guys. By God bless. We'll catch us in our next video.